Hey Calc students! So today we're going to be working on the derivative of log functions. So think back to pre-calc, the end of Algebra 2. Do you remember what the log properties are? So there are three of them. Log A plus log B equals log A times B. So remember that multiplication turns into addition, or addition into multiplication, however you want to think about it. When you're subtracting, that's division. So log of A over B. And then lastly, when you have log of x squared, like that, or x to the n, I'll make it x to the n. That's n log x. Now, that is different than, say, log x squared. Those are two different things. This one is not equal, right? Or x to the, I changed it to 2 again, x to the n. Those are not the same thing. So it's the inside being raised to the power, right? The inside being raised to a power, then it's allowed to come in front. Two different things. Okay, so let's just do a review of exponentials since we're doing their inverses. So go through and pause the video, find the derivative of all of these. So the derivative of e is just e. Now, I don't know if you remember this one because we don't do a lot of it. The derivative of an exponential, we rewrite it and then we multiply by ln of the base. All right, so that's it. Number 3, derivative of e, you rewrite it, and then derivative of our exponent, cosine x. I would write that as cosine x, e to the sine x. It looks a little nicer. All right, so again, whenever you have an exponential, we're going to rewrite it. 5, 2x minus 1, ln of the base, so ln of 5, and then also times the derivative of the exponent, 2. So maybe a nicer answer would be 2 ln of 5, 5 to the 2x minus 1. Running out of space here. All right, g prime. All right, so we got the derivative of the top is 2x minus 2 times ln of the base, ln of 3, and then we rewrite it. Whew. All right, and then this last one, I'm going to kind of give myself a little more space here for 6. H prime equals. So we have ln of 4. We're going to rewrite it. And then times, we have a product rule, right? X cosine x, derivative of the first, times the second, plus the first, derivative of the second. Derivative of cosine is negative sine. All right. All right, so who remembers, what was our rule for inverses that we talked about last week? When you take the derivative of an inverse, it's really 1 over the derivative of the regular function, right? So that's kind of the reasoning behind the derivative of ln of x. Now, I know a lot of you looked it up from our last problem set. You looked up the derivative of ln of x is just 1 over x. All right, so again, that big time memorization there. Big time memorization. The derivative of log base a, it's really similar if you remember the derivative of a to the x. If we had this, we rewrote it, and then times ln of a. Very similar. Ln of x is 1 over x, so it's 1 over x, and then in the denominator we have ln of a. It's not erasing. So it's 1 over x times 1 over ln of a is basically what it is, right? 1 over x times 1 over ln of a. But we put it in one big fraction. If you want the proof of it, you can look it up. It's in the book. All right, so practice these. Pause the video, do it on your own. All right, so f prime, this is a chain rule, so 2 times ln of x times the derivative of the inside, 1 over x. Done. Number 2, 1/2 times 1 over x over ln of what number? What's the base there? That's base 10. It's like awkward looking. So that's 1 over 2 ln of 10x. All right, next. Ooh, this one has a y in it. So let's see what's going to happen here. So the derivative of ln of x is 1 over x, sorry, plus ln of y, 1 over y dy dx equals 2. So now let's solve for dy dx. 1 over y dy dx equals 2 minus 1 over x multiplied by y on both sides. So we get 2y minus y over x. That's it. All right. So now this one, we've got h prime 1 over x to the third ln of 2 times the derivative of the inside, 3x squared. Now, there's actually an easier way, and we can actually figure it out pretty easily. Remember, this is an exponent, right? So that h can also be written as 3 log base 2 of x. So h prime would be 3 times 1 over x ln of 2. And notice we can simplify. This top one, x squared, goes in x cubed, so you get the 3 over x ln of 2. So you do get the same answer. All right, try these. Y prime equals, so ln, so these are the nice ones, right? No ln of a number, 1 over 5x times the derivative of the inside, 5. So you notice you get 1 over x. Why do you get 1 over x? So what's another way of writing ln of 5x? So that's ln of 5 plus ln of x. What's the derivative of ln of 5? Ln of 5 is a constant number, so it's just 0. So that's why we get 1 over x. All right, 6. Not so nice. You can't simplify the ln of x squared plus 1. You just got to go through the motions. So product rule, derivative of the first times the second plus the first, 1 over times the derivative of the inside. So typically when I have an ln of, say it's ln of u, I write it as u prime on the bottom and u on top. That's usually how I write it. I don't usually do 1 over the function times the chain rule. I usually just put the derivative. I wrote that backwards. I just realized as I'm talking. The function goes on the bottom, the derivative goes on top. It's really 1 over u times u prime, right? But I like writing it like this. I think it's nicer looking. Okay. I want you to pause. I want you to just think about this. This is terrible, right? Think about, there is an easier way. What would be an easier way to do this problem other than 1 over times a product quotient rule? So think about our do now. What are the log properties? Multiplication is plus, division is minus. So I can rewrite this entire problem as ln of x cubed plus 1 plus ln of the square root of 2x to the 4th plus 1 minus ln of x. And also what I did was I then rewrote this. This is 2x to the 4th plus 1 to the 1/2, and I brought that 1/2 down front. So f is ln of x cubed plus 1 plus 1/2 ln 2x to the 4th plus 1 minus ln of x. So normally using those properties makes things so much more difficult. In this case, our answer is so much easier to do. The derivative of this is significantly easier than the original. So in ln, so x cubed plus 1 goes in the bottom, derivative on top. Inside on the bottom, derivative on top. Done. Right. That is way easier than doing 1 over that craziness product quotient rule. That's horrible. We do not want to do that. Do not want to do that. And that's the wonderfulness that is the log function. All right, same idea. Pause it, try it on your own. So I'm going to rewrite this. This becomes ln of x squared plus ln of the square root of 5x plus 1 minus ln 3x minus 2 squared. So then I'm going to rewrite it to make it even nicer. 2 ln of x, 1/2 ln of 5x plus 1 minus, I wrote that wrong, that's a 3. 3 ln of 3x minus 2. So now I simplified my function. Now I'm going to, oopsies. Take the derivative, f prime, 2 over x plus 5 over 2 times 5x plus 1 minus 3 times 3 over 3x minus 2. And you can simplify that. I almost wrote 9 over 3x minus 2. It's really up to you. But that's your answer. All right. Y equals x to the x. Think about what we just did. So we can't do this the way it is. So what we're going to do is we're going to use the ln. So I'm going to take the ln of both sides. Ln of y equals ln of x to the x. Now what can I do to that? I can bring the x down front. So now I'm going to take the derivative. What's the derivative of ln of y? 1 over y dy dx equals, it's a product rule, derivative of the first times the second plus the first derivative of the second. And now I'm trying to figure out dy dx. So we're going to multiply by y. We're going to multiply by y over 1, right? That whole thing gets multiplied by y. So then dy dx equals ln of x. I'm going to simplify that to 1 times y. But what's y? Y is x to the x. That's it. So we have to remember, if you have an x to x, we don't know how to do that. We have to use the log properties. All right, last one. Same idea as the last one. Try it. So I have y equals x, the square root, x squared plus 3 over 1 plus x. I need to do the ln of both sides because I don't want to do the product quotient rule. I made you do that earlier, but now we can cheat. So we're going to do the ln of both sides. So ln of y equals ln of x plus 1/2 ln of x squared plus 3 minus the ln of 1 plus x. Derivative of ln is ln of y, 1 over y dy dx equals 1 over x plus 2x over 2 times x squared plus 3 minus 1 over 1 plus x. So dy dx equals all of that all times y. And y is that original function. Whew. That's a lot. All right, so now we're going to plug in. It says find the tangent line, so now we're going to plug in 1, right? So we're going to plug in 1, 1. Let's see if we can get, oof. All right, we can do this. I'm running out of space. All right, so we get 1 plus 2 over, if I plug in 1, I get 2 times 4, 8, minus 1/2, times, now I'm plugging in 1, the square root of 4 over 2. Not that bad. All right, let's see. I got a 1/4 minus 2/4. So we get 1 minus 1/4, so that's 3/4. And then, that's just 1. So 3/4. So y minus 1 equals 3/4 x minus 1. And we're done. All right, there is your homework. 5 through 75, do the multiples of 5. All right, so 5, 10, 15, 20. So it's actually not that bad. I was having trouble deciding which ones to do. So 5 through 75 multiples of 5. All right, have a fabulous day.